Everyone says cardboard is compostable, right? But what if I told you that simple truth is hiding a much bigger, more complex problem? Today we're dissecting the inks used on your everyday cardboard boxes. You might be surprised to learn what's truly going into your compost, and more importantly, what's not breaking down. As fellow gardeners who care deeply about soil health, we need to talk about the elephant in the room. Those colorful inks coating nearly every piece of cardboard we throw into our compost bins. Your delivery boxes are piling up faster than ever before. Amazon packages, food delivery containers, and product packaging have made cardboard the most abundant waste stream in many households. We've all been told that cardboard is a fantastic brown material for composting, and technically that's true. The cardboard itself, being made from recycled paper fibers, breaks down beautifully in a well-managed compost system. But here's where things get complicated. The inks printed on that cardboard tell a completely different story. While you're watching your cardboard decompose over months of turning and watering your pile, those vibrant logos, shipping labels, and colorful graphics aren't disappearing at the same rate. In fact, many of these inks contain synthetic chemicals that don't break down at all during the composting process. Instead, they're quietly infiltrating your finished compost with compounds that can persist in your soil for years. This isn't just an aesthetic issue. We're talking about potential toxins that could affect everything from your tomatoes to the beneficial microorganisms that make your soil thrive. The scale of this problem is staggering when you consider how much printed cardboard enters home composting systems nationwide. Every shipping box, every cereal container, every pizza box carries with it a cocktail of ink chemicals that most gardeners never consider. These materials are entering our compost systems in such volumes that we're essentially conducting an uncontrolled experiment with our soil health, and most of us don't even realize it's happening. So understanding what's actually in cardboard inks requires us to think like chemists for a moment. Traditional printing inks used on cardboard packaging rely heavily on petroleum-based solvents and synthetic pigments. These formulations include phthalates, which are plasticizers that help inks maintain flexibility and adhesion to cardboard surfaces. Now, phthalates are endocrine disruptors that have been linked to reproductive health issues and developmental problems, and they just don't readily biodegrade in compost environments. Volatile organic compounds, or VOCs, represent another significant concern. These chemicals evaporate easily at room temperature, which is why fresh cardboard sometimes has that distinct chemical smell. While some VOCs will off-gas before reaching your compost pile, others bind to the cardboard fibers and can persist throughout the decomposition process. Toluene, xylene, and various ketones commonly found in printing inks can accumulate in compost and potentially inhibit beneficial microbial activity. Perhaps most concerning are the heavy metals used as pigments in many cardboard inks. Lead, cadmium, chromium, and mercury have historically been used to create vibrant colors, and while regulations have reduced their use in recent years, they're still present in many imported packaging materials. These metals don't break down ever. Once they're in your compost, they're in your soil permanently, where they can accumulate to toxic levels over time and potentially enter your food chain through plant uptake. The complexity increases when you consider that different types of cardboard use different ink formulations. Corrugated shipping boxes might use simple flexographic inks, while retail packaging often employs more complex offset or digital printing systems with additional coatings and treatments. Each system brings its own set of chemical concerns, making it nearly impossible for home composters to know exactly what they're dealing with just by looking at a piece of cardboard. The journey from ink to soil contamination isn't immediate or obvious, which makes this problem particularly insidious. As your compost pile heats up and microorganisms begin breaking down organic matter, many ink components resist decomposition. Instead of biodegrading, these chemicals leach into the composting matrix, binding to organic particles and eventually becoming incorporated into your finished compost. When you spread this compost in your garden beds, you're inadvertently introducing these contaminants directly to your plant root zones. Research has shown that certain ink components can significantly impact plant development. Phthalates, for instance, can interfere with plant hormone systems, leading to stunted growth, reduced flowering, and compromised fruit development. Heavy metals present an even more serious concern, as they can accumulate in plant tissues and potentially pose health risks if you're growing edible crops. Lead contamination in garden soil has been linked to reduced yields in leafy greens and root vegetables, while cadmium can interfere with nutrient uptake and stress plant immune systems. The microbial ecosystem in your soil also suffers when exposed to ink contaminants. Beneficial bacteria and fungi that are essential for nutrient cycling, disease suppression, and soil structure formation can be sensitive to chemical disruption. Studies have documented reduced microbial diversity in soils contaminated with printing ink residues, which translates to less resilient soil biology and potentially more disease pressure on your plants. Beyond immediate plant health concerns, there's the cumulative effect to consider. Each batch of compost you make with ink-contaminated cardboard adds to the total chemical load in your soil. Over multiple growing seasons, these compounds can build up to levels that significantly impact soil health and productivity. This is particularly concerning for dedicated gardeners who pride themselves on building healthy, living soil through composting. The good news is that the packaging industry is slowly responding to environmental concerns, and there are increasingly better options available for conscious composters. Vegetable-based inks, derived from soybeans, corn, or other plant materials, offer a much safer alternative to petroleum-based formulations. These inks typically break down more readily in compost systems and don't carry the same heavy metal or VOC concerns. When shopping, look for packaging that specifically advertises soy-based or vegetable-based inks. Many environmentally conscious companies are starting to highlight this on their materials. Water-based inks represent another significant improvement over traditional solvent-based systems. These formulations eliminate most VOC concerns and often use safer pigment systems. While they may still contain some synthetic components, the overall environmental and health profile is dramatically better than conventional inks. Food packaging in particular is increasingly moving toward water-based systems due to safety regulations around food contact materials. For the hands-on composter, there are practical steps you can take right now to minimize ink contamination. The most effective approach is selective removal of heavily inked areas before adding cardboard to your compost. This means cutting away shipping labels, removing tape and adhesive residues, and avoiding pieces with dense ink coverage like logos or graphics. It's a bit more work, but the payoff in terms of compost quality is honestly significant. Pre-weathering cardboard can also help reduce ink contamination. Leaving cardboard outside for several weeks before composting allows UV light and moisture to begin breaking down some ink components and helps volatile compounds off-gas naturally. This won't eliminate all problems, but it can reduce the chemical load entering your compost system. Becoming an informed compost steward starts with developing an eye for identifying potentially problematic cardboard. Glossy or heavily coated cardboard should be avoided entirely, as these materials often contain plastic coatings and more complex ink systems. Bright saturated colors, particularly reds and oranges, are more likely to contain heavy metal pigments. Cardboard with metallic inks or special effects coatings should never enter your compost pile, as these almost certainly contain non-biodegradable synthetic materials. The most practical approach for most gardeners is implementing a two-tier system for cardboard composting. Clean, lightly printed cardboard with minimal ink coverage can go directly into your regular compost system. This includes many shipping boxes, plain food packaging, and simple corrugated materials. More heavily printed materials should either be avoided entirely or processed through a separate, longer-term composting system where you can monitor the breakdown more carefully and test the finished compost before using it on food crops. Testing your finished compost is becoming an increasingly important practice for serious gardeners. Basic soil testing can reveal heavy metal contamination, while more specialized testing can identify other chemical residues. Many university extension services offer compost testing programs, and home testing kits are becoming more sophisticated and affordable. Consider testing compost made with significant amounts of printed cardboard, particularly if you're growing food crops or if you've been composting printed materials for several years. As consumers, we have more power than we realize to influence packaging decisions. Companies are increasingly responsive to customer feedback about environmental concerns, and many are actively seeking ways to improve their packaging sustainability. Reach out to brands whose products you frequently purchase and ask about their ink choices and overall package compostability. Supporting companies that prioritize truly compostable packaging sends a clear market signal that consumers care about these issues. The future of composting depends on our collective commitment to understanding and improving our practices. By staying informed about the materials we're adding to our compost systems, we can continue building healthy, productive soils while avoiding the unintended consequences of chemical contamination. Your compost pile is a reflection of your values as a gardener. Make sure it's contributing to the healthy, sustainable growing environment you're working so hard to create. Remember, every small step toward cleaner composting practices contributes to healthier soil, more productive gardens, and a more sustainable food system. Your efforts to understand and address the ink problem in cardboard composting are helping to protect not just your own garden, but the broader environment we all share. If this deep dive into cardboard ink chemistry has opened your eyes to the complexities of sustainable composting, make sure to subscribe to the Living Soil Lab for more science-backed gardening insights that go beyond the surface. Share this guide with fellow gardeners who deserve to know what's really happening in their compost piles. Together, we can build a community of informed, soil-conscious growers who understand that healthy gardens start with understanding every input we add to our systems.